An electric current is a measure of the rate of flow of electric charge through a conductor. To make a current flow through a conductor, we need a closed loop. We also need an energy source. Now note that the conducting material already has free charges inside it. Once we close the loop and connect to the power source, those charges are going to be pushed around the entire closed loop like that. That is what we call an electric current, as charge flows through the entire conductor. Current is measured in amperes using a device called an ammeter. The direction of an electric current is of interest to us. Why? Primarily because there are two types of current that exist in a circuit. Okay? The first kind of current can be termed the electron current. This current, we can visualize this as electrons flowing from the negative pole of a battery to the positive pole of a battery. So this is an electron current. Electrons flow in the entire circuit. There is also another type of current where positive charges move around the circuit in the closed loop as well. Note that the positive charges go from the positive terminal to the negative terminal. We call this conventional current. In most of the circuit diagrams you guys will be encountering in high school, we will take the direction of current as the conventional current. That is to say, current will flow from the positive terminal to the negative terminal of the battery. The equation for electric current I, say I is equal to delta Q over delta T. Delta Q represents the charge transferred in coulombs and delta T the time in seconds. Suppose a charge of 0.6 coulombs flows past a conductor in 3 seconds. What will the electric current be? Apply the equation I is equal to delta Q over delta T. We will get 0.6 over 0.3. The current in that circuit will be 0.2 amps. Amperes are thus a measure of the charge per second. 0.2 amps, 0.2 coulombs per second, 10 amps, 10 coulombs per second. The equation I equals delta Q over delta T can be used to calculate either the charge, the time, or the current. By using this unique triangle, we can place all three quantities inside this triangle and then use this triangle to solve the problems that we need to solve. For example, to calculate delta Q, we simply take the product of the current and the time. So delta Q equals I times delta T. To calculate the time, we simply take the ratio of the charge and the current. So delta Q over delta I. A current of 1.2 amps flows for 2 minutes. How much charge is delivered? Use the formula. Delta Q is going to be equal to I times delta T. So delta Q is equal to 144 coulombs. What if we want to find the time it takes for a current of 0.15 amps to deliver 108 coulombs of charge? By using the same triangle again, we can discover that delta T is equal to delta Q over delta I. And this will give us a total of 720 seconds. Well guys, that's the basics of electric current, charge and time. Once we learn how to do this simple 3-step calculation, it forms the basis of other calculations involved in current electricity. For now, you're going to do some practice problems. You can pause the video, and then when you're done with your calculations, press play. The solutions will be added at the end of the video. It's time now for some practice problems. At this stage, you can pause the video, work through the problems. Once you get your answers, check with the solutions that we've provided. If you don't get the same answers, please do write to us and let's argue as scientists. Problem number 1. Calculate the current if 6 coulombs of charge is delivered in 1 minute. Problem number 2. A current of 0.75 amps flows for 1 hour. Calculate the charge delivered. Problem number 3. How long does a 0.11 amp current take to deliver 3.5 coulombs of charge? Now, these 3 problems are based on these 3 quantities: charge, current, and time. We have said the current is equal to the rate at which charge flows. So I is equal to delta Q over delta T. The first one, we simply use the formula to calculate the current. I is equal to delta Q over delta T. But make sure that the time must always be in seconds. In this question, the time is given in minutes. You convert the minutes to seconds. If the time is given in hours, convert the hours to seconds. So 6 coulombs divided by 60, because 1 minute is 60 seconds. This will give us a current of 0.1 amps. Problem number 2. To calculate the charge from the triangle, you can see that delta Q is the product of current and time. Delta Q equals I delta T. The current is given as 0.75 amps and the time given is 1 hour. We need to convert the 1 hour into seconds. How many seconds are there in an hour? 3,600 seconds. 60 seconds in a minute and 60 minutes in an hour gives us 3,600 seconds. Multiplying the 2, we get the total charge delivered is 2,700 coulombs. Number 3, we want to calculate the time. Again, using the triangle, we can see that delta T is the ratio of the charge to the current. In other words, delta T equals delta Q divided by the current. So the charge in this case is 3.5 coulombs and the current is 0.11 amps. Dividing the 2, we get 31.818181 and it goes on like that. So these are the seconds that we've calculated. And by rounding them off to maybe 2 decimal places, we end up with 31.82 seconds. Remember to round off to 2 decimal places. Look at the third number after the comma. If that number is greater than 5, round off the number on the left of that number to the nearest whole number. In this case, the third number on the right of the comma is 8, and it's greater than 5, so we need to round off the 1 on the left hand side to the 2. So we end up with 31.82 seconds. Thank you guys for watching. That was the basics of electricity part 1. In the next video, we'll develop more ideas surrounding potential difference, the EMF, and we'll also go on to talk about resistance in other videos and resistance networks as well as internal resistance. So stay tuned for more of those videos coming up. We hope you enjoyed it. See you guys around next time.